Hello everyone, good morning to all. So in today's lecture, we will do D'Alembert's ratio test, Rabi's test as well, and the Cauchys root test. Now try to understand that what exactly is D'Alembert's ratio test. This test is used for the test for the convergence of an infinite series, D'Alembert's ratio test. Now see, what exactly is this test stating? According to this test, the statement is if summation un be a series of positive terms such that limit n tends to infinity un upon un plus 1 is equal to L. Then this test is stating that then summation un is convergent if this limit L is more than 1, and summation un is divergent. It is divergent if this L is less than 1, and test fails if L is equal to 1. Now try to understand it, that where we should apply this test. I told you that if the nth term of the series, where to apply this test, where to apply, and type of the series. Normally we prefer series containing factorial, number one, and number two is the series having increasing power of x, or some reoccurring product. Now reoccurring product of the type, suppose is of this type 1 into 3 into 5 till 2n minus 1, this type of thing. Now let us consider one by one some problems. So the problems are something like that. The first problem 1, the question is test for the convergence for the series 1 plus 2 factorial by 2 square plus 3 factorial by 3 square plus 4 factorial, sorry, it is 3 cube rather than square, 4 factorial is to power 4, and so on. So what I will do here, now we have to test for the convergence, whether the series is convergent or divergent. So first step is write its nth term. You will see that the nth term is n factorial by n raised to power n. Now what is our un plus 1? That is equal to n plus 1 factorial upon n plus 1 raised to power n plus 1. Now let us find the limit n tends to infinity un upon un plus 1. It will goes like this, n factorial by n raised to power n and n plus 1 raised to power n plus 1 upon n plus 1 factorial. If I simplify this, it is limit n tends to infinity, it is n factorial, it is n plus 1 raised to power n plus 1, n to the power n, it is n plus 1 into n factorial. This will get cancelled with it, and there will be one power less of it. So we have this expression, limit n tends to infinity, n plus 1 upon n raised to power n, and this will be nothing but 1 plus 1 by n raised to power n. And guys, this limit is e, and e is more than 1, so therefore the series is convergent. So this is the way that you can simplify such type of problems. Now let us consider one more problem, problem 2. The question is test for the convergence. Test for the convergence. The series is something like this: 1 by 3 plus 1 into 2 into 3 into 5 plus 1 into 2 into 3 upon 3 into 5 into 7 plus 1 into 2 into 3 into 4 upon 3 into 5 into 7 into 9, and so on. Now guys, what will we do here? I am writing its nth term. Now if you see the pattern, that in the numerator the product is increasing, in the second term there is a product of two terms, so my nth term will be like this: 1 into 2 into 3 into till n, and 3 5 7 it is in AP, so its nth term will be 3 plus n minus 1 into common difference 2. That is equal to, my nth term will be equal to, can I write a numerator as n factorial? Yes, upon 3 into 5 into 7 till 2n plus 1. Now the next, guys, I will write un plus 1, that is n plus 1 factorial upon 3 into 5 into 7 2n plus 1, and the next term of it 2n plus 3. Now what I will do, if I take the ratio of limit n tends to infinity un upon un plus 1, then it will be n factorial upon 3 into 5 into 7 2n plus 1, 3 into 5 into 7 2n plus 1 into 2n plus 3 upon n plus 1 factorial. Now this term will get cancelled with it, and now let us adjust this n factorial as well. So we have n factorial into 2n plus 3, and we can write this n plus 1 factorial as n factorial into n plus 1. This will get cancelled. Now let us take the limit of it. Limit n tends to infinity. So what will we do? Take the highest power of n common. So n 2 plus 3 by n upon n into 1 plus 1 by n. Now you will find that this, guys, this limit is 2, more than 1. So series is convergent. So it's not so difficult, guys. The only thing is that you have to keep in your mind that how the series behave. Now let us discuss another type of problem on the ratio test. The problem 3 is test for the convergence. Test for the convergence x upon 1 into 3 plus x square upon 3 into 5 plus x cube upon 5 into 7, and so on. As I told you that when the series is containing increasing power of x, then it's a clear cut suggesting that the question is of ratio test. Now first step is write the nth term, that is x raised to power n. Now if you recognize this 1 into 3, 3 into 5 is forming an AP. So 1 3 5. So if I write its nth term, that is 1 plus n minus 1 into common difference of 2. The next is 3 plus n minus 1 of 2. So I have written like this. Now my nth term will be equal to x raised to power n upon 2n minus 1 into 2n plus 1. So now this term is ready. Now the next is, what is n plus 1 term? That is x raised to power n plus 1. Now replace n by n plus 1. So it will be 2n plus 1, 2n plus 3. Now let us take the limit of it. Limit n tends to infinity un upon un plus 1. So guys, this will be nothing but it will behave like this: 2n minus 1, 2n plus 1, and here again 2n plus 1, 2n plus 3 upon x raised to power n plus 1. Now this will be cancel one, this power, this will get cancelled with it. So we will be having limit n tends to infinity. Try to understand it, what the way that this will reply. In fact, act this limit on it. Now x is independent of limit, so take outside. Now take the highest power of n common, 2 plus 3 by n and 2 minus 1 by n. So this limit is 1, that is 1 by x. So what can I conclude here? So by ratio test, series is convergent if 1 by x is more than 1, that is x is less than 1, and series is divergent if 1 by x is less than 1, that is x is more than 1, and the test fails if 1 by x is equal to 1. This will imply x is equal to 1. Now this is the important point, guys, because at x equal to 1 the ratio test fails, but there has to be some nature of the series. So what I will do, when my x is equal to 1, now see what will happen of the nth term, un. Your un will become simply 1 upon 2n minus 1 and 2n plus 1. Like this. Now guys, it is a question of clear cut limit comparison test. So what I will do, I will take n common entirely, n square, like this. I define Vn as 1 by n square. Now by LCT, limit n tends to infinity, un by Vn will be like this. Limit n tends to infinity. Now let us make use of the test. So this n square will get cancelled, so I will be having only this limit, 2 plus 1 by n. So this limit is nothing but 1 by 4, which is finite and non-zero. So therefore summation un and summation Vn behaves alike. But summation Vn, which is equal to summation 1 by n square, compare with the p test, p is 2 more than 1, convergent. So you can say that clearly here. When x is less than or equal to 1, the series is convergent, and x is more than 1, the series is divergent. This is the final nature on the basis of x, because when the series is involving x, the guys, your role is to find for what value of x exactly the series is convergent. So your role is just to find the value of x. Now guys, now the next test we have Cauchy's root test. Try to understand that what exactly Cauchy's root test states. Cauchy's root test. Cauchy's root test. The statement is again, if summation un is a series of positive terms such that limit n tends to infinity, nth root of the nth term if we take, and it is turning out to be L. If this L is less than 1, the series is convergent. L is more than 1, the series is divergent. And at L equal to 1, test fails. Now we'll discuss few questions on this, because the most of the question coming out to be directly here. The first question is, discuss the convergence of n1 to infinity n upon n plus 1 raised to power n square. Now how will we discuss it? Now our nth term is n upon n plus 1 n square. Now take the nth root of it. I have taken the nth root of it, so, and we have to take the limit as well. Limit n tends to infinity. Limit n tends to infinity, it is turning out to be n upon n plus 1 raised to power n. Can I write this, guys? Limit n tends to infinity, 1 upon n plus 1 upon n whole to the power n. Yes, of course I can write it. This is nothing but of course I can write this as limit n tends to infinity, 1 upon 1 plus 1 by n raised to power n. This is nothing but 1 by e, which is less than 1. So series is convergent because my e is always greater than 2 and less than 3. Guys, please do remember this formula, limit n tends to infinity, 1 plus a by n raised to power n is e raised to power a. This is very helpful formula while solving the problem based on this Cauchy's root test. Now let us discuss one more problem on Cauchy's root test. Try to understand that what exactly is the problem. The question is, test for the convergence (1 by 2 plus 2 by 3 of x plus 3 by 4 square of x square plus 4 by 5 cube of x cube, and so on. Now guys, try to understand that what I will do. In an infinite series, we can the nature of the series does not change if we leave finite number of terms. So I'm leaving my first term to get the nth term of it. So my nth term I'm writing this way, because this is nothing but n plus 1 upon n plus 2 raised to power n into x to the power n. Now what I will do, take the nth root of it, limit n tends to infinity. What will happen? It will be n plus 1 upon n plus 2 into x. This limit is turning out to be x. So therefore by Cauchy's root test, series is convergent if x is less than 1 and diverges if x is more than 1. Now what will happen when x is equal to 1? When x is equal to 1, my nth term will be simply n plus 1 upon n plus 2 whole to the power n. Now guys, what I will do of it, taking the nth root of it, or rather than this, what I will do, there is another way of approaching it. I can write this as dividing numerator and denominator by n. We can do it. Now if I try to find this limit, it is 1 upon 1 by n raised to power n, and it is 1 plus 1 2 by n raised to power n. If I take the limit of numerator and denominator separately, because these limit exist, it is e upon e square, that is 1 by e, is not equal to 0. So therefore series is divergent, because there is a necessary criteria. If the limit of nth term is not equal to 0, then the series is divergent. So this is the nature of the series, guys. Okay, now let us consider one more problem here. Let us discuss. There is another problem. The question is, discuss the convergence of summation 1 plus 1 by root n raised to power minus n raised to power 3 by 2. So what I will do, my nth term is given 1 by root n raised to power minus n raised to power 3 by 2. Now let us take the nth root of it. So I will be having 1 plus 1 by root n minus n raised to power 3 by 2 upon n. It is nothing but limit n tends to infinity, 1 plus 1 by root n is to power minus root n. I can write this as, try to understand it, that how it will behave. I can write this as 1 plus 1 by root n raised to power root n and whole to the power minus 1. So the limit inside is e raised to power minus 1, that is 1 by e, that is less than 1. So series is convergent. So guys, I hope आपको ये lecture most probably you must like it, and please subscribe to the channel. Thank you everyone for watching it and bearing with me.